Hey everyone, my name is Taylor. Today I'll be discussing how to use the spot welder at the Aeromaker space here at Georgia Tech. So first of all, what is a spot welder? A spot welder is essentially a very large capacitor that stores electrical charge and discharges it across two tiny electrodes, creating a weld between two thin pieces of metal. It is most commonly used in battery pack manufacturing. So first you start off with a battery pack, collection of lithium-ion cells in particular, and you have to create a structure to hold them together, and you need to figure out how to link them all up to create a battery with higher storage capacity or voltage. The end goal here is to produce a weld across different cells, as shown here, such as to create a larger capacity battery to use in, say, an electric scooter. But before diving deeply into the training, it's important to discuss safety. Before you use the spot welder in any capacity, you should bring three things to the table. First, safety glasses. Second, some thermally protective gloves. And third, a knowledge of good battery design practices. When discussing battery manufacturing, you might hear the SP configuration terminology thrown around a lot. What this means is that, for example, if you have a 5S 2P battery pack, that means you have 5 cells in series and 2 in parallel. So what this looks like in a circuit schematic is 1, 2, 3, 4, 5, all connected in series, and you have another row of 1, 2, 3, 4, 5 connected in parallel. And what this does, as I said before, is that it will increase the overall capacity. It will multiply the capacity by 2, since there are 2 rows in parallel, and it will multiply the individual cell voltage by 5S 2P. So if each individual cell was 3.6 volts nominally, then you'd have 3.6 by 5, which is 18 volts for the overall battery pack at a capacity double that of the original cell. So if the original cell was 2 amp hours, this entire battery pack would be 4 amp hours. Now, understanding the circuit configuration for the battery pack is very important, because what you do not want to do is short your battery pack. If you spot weld a battery pack that is shorted, it could blow up within a few minutes. So it is very important that you understand what you were spot welding before you set up the spot welder. Now I will be explaining how to manufacture a battery pack using the spot welder. Like I said before, this is essentially a large capacitor, so you'll need to charge it up for, I think the manual says 30 minutes before using it usually. You'll know if it's fully charged up based off the voltage. I think the manual says it must be 5.2 to 5.8 volts in order to be fully charged. So you can see now it's at 5.77, so it's good to go. I was already charging it for a while beforehand. The next thing you will want to do is set how much power you will want to set for the individual weld itself. So you have a nickel strip, and your goal is to adhere it to the battery pack like so, right? So first you can cut it to length, this. You see, it will go across from one cell to the other, it's the right length. And then to set the power on the machine, you want to measure the thickness of the nickel strip. And this one is 0.11 millimeters. You can see that in the manual, it recommends that 0.11 millimeters for a pure nickel, you set to 10 to 11 T. So right now it's at 25 T, so I'm going to move it down to 11 T. And right now it's set in automatic mode. You can also do another mode where you use a foot pedal and you use a manual press down lever, like so. And if you want more precise spot welding, then this can also work, but this is definitely much easier to use and arguably much safer. So the first thing you want to do is put on your thermally protective glove before you do any spot welding. Now that it's set to the right power level, I'll bring over the battery pack like so.
I will double check to make sure I'm not shorting any of the battery cells. There's nothing connected on the other side, so I know that there's no way I could be shorting it. I will put them on between the two cells that I want to connect, like so. Like so. Takes a little finicking. Okay. And you can see it's at 11T. And what this does is that these are two spring activated copper electrodes. So once you push down with them with enough force, it releases the stored charge within the capacitor and creates the weld. So I will just place down the electrodes on where I want to spot weld. And as you can see, it just came back up and it's stuck on the nickel strip. Gosh dang it. Wow, what should I do? Well, as I've discovered with this particular spot welder is that it's quite weak. So generally you'll want to increase the power a lot more, but what's listed in the manual can be a good starting point as it varies significantly based off the thickness of the electrode. So what happened was that it couldn't generate enough current to create enough heat to form the weld, to go all the way through the metal and hit in to adhere to the battery cell. So it adhered to the electrodes instead. So to avoid that, we simply increase the power a little bit. It was at 12. I'm going to move it up to, let's start with 18. And I will, I'll put it back down. You can reuse a strip as long as it doesn't go all the way through and it creates like a hole. And if you have a sufficient room to create a weld on, you can just reuse a strip. I'll put it back down where I wanted it to go, like so. And I will try going again, pressing down. Oh, did it again. So it's still not high enough power. I will increase it to 24. And try again. And as you can see, it's stuck all the way down. So that's how I know the weld is good by if I wait a few seconds until it cools down and I tap it a little bit. After a while, you'll gain a feel for if it's fully adhered or if it still is loose. And if it's loose, you can just weld it again. As long as you're not welding in the exact same spot, it's okay to keep welding on top of welds or welding next to welds. If you weld on the same spot, you might find that it'll puncture a hole through the weld, and you'll have to do it over again, which is not the end of the world. The biggest danger here is potentially burning your finger by getting close to the electrode. So you want to make sure your hand that is using the spot welder has a thermal glove on it. And my free hand, if you can use a glove in your free hand, is not like right near where I'm spot welding. That's the danger. So as you can see, what happened is that there's a huge spark right there. What that essentially meant was it went all the way through the nickel strip. So in that case, I might choose to lower the power just a little bit, or what could have happened was I tried to spot weld a little bit too close to an existing weld and it created a hole. So I will try. Great, so I successfully created the second weld. If I were creating this battery pack for real, I might want to redo that just a little bit because it seemed to create a lot of holes on top of the nickel strip. And what will end up happening is if I'm creating the series, this battery pack, I will want to mate these two cells to these two cells like so. And it might be better to have a cleaner strip toward the bottom, but it doesn't really matter that much. So what happens next is that you keep going, you repeat the process, you measure approximately the right length for the nickel strip. I will double check that I'm not shorting any batteries. The other side, I'm not. And I can bind these two cells together, like so. I have the same power level, so I just can go down very carefully, approach the battery pack, push down with a little bit of force. Okay, as you can see, that weld did not work, so I will use the glove to pull that off again and just repeat this process throughout the battery pack. Thank you all for listening. That is the introduction to using the spot welder. Be careful, don't burn your fingers off.